Hi, everyone, and welcome to our session today. My name is Bert Schrijver, and we're going to talk about understanding the Log4Shell vulnerability. And I'm happy to introduce my colleague, Roy van Rijn, to you.
Hello.
So Roy has worn his hacker outfit for today. We're going to look into the details of the recently published Log4Shell vulnerability. Roy has prepared some demos and code examples for us. And we're going to take about 40 minutes to look into some of the background of the vulnerability, some actual live demos, and we're also going to look at remediations and things you can do after you found out that you have been or might have been vulnerable.
Yeah, not can do, have to do.
Like have to do, exactly. Yes, we're going to give you some sound advice, hopefully. So as we are live on YouTube at the moment, feel free to join in through the YouTube chat. While Roy is demoing, I'll watch the chat for any questions that you might have, and I'm happy to relay them to Roy. So let's get started. We're going to talk about, well, introduce the vulnerability, give you an overview. We'll do lots of live demos. We'll talk shortly about a comparable issue that's been found in Logback. We'll talk about remediation strategies. So what can you do to prevent being affected? We're shortly going to look into a hot patch for Log4Shell. We're going to talk about the live after Log4Shell, and there'll be lots of room for questions and answers. So if you have any questions, please drop them in the YouTube chat, and then we'll be happy to help you out with this. So before we start, I'll set up the stream. So I'm currently both presenting and DJing the stream. So pardon me if I need to fix some things every now and then, but we're looking good to go. So what is Log4Shell? It is a 0-day vulnerability, which means that it's a vulnerability that is published when a developer has basically 0 days to fix it. So it's in Log4j, which is I think one of the most popular Java logging frameworks you probably all know. And the risks are code execution, which means that an attacker can execute a code on a vulnerable application, and leaking of environment variables. So this was publicly disclosed last week, and I think we can safely say that it took the Java world by storm because of its widespreadness. So what it does is it takes advantage of a feature in Log4j that allows requests to LDAP and Yindi servers, and not validating responses, basically allowing attackers to execute custom code on the server or leak sensitive information. So you might ask, what is Yindi? It is the Java naming and directory interface, and it's an API for a directory service. So a directory service is comparable with a phone book that allows Java software to look up data. So you can query, for example, LDAP servers and DNS servers, and look up resources in the form of Java objects via name. So you configure a name, then you can use Yindi to look up data and resources. So if you look up information via Yindi, it may be supplied by a remote server. It could be LDAP or DNS, could be a file, could be a database. The choice is up to the implementation used. So if you have built applications with Java EE or Jakarta EE in the past, then you probably know Yindi because you were looking up, I don't know, data sources or something in the application container. So you can look up data sources, make DNS entries, make LDAP entries, and even fetch Java objects. And this is, I think, the main reason that we're in this vulnerability now, the ability to fetch Java objects. So why does a logging library need or support Yindi? So this goes back to a Log4j issue from 2013, where somebody requests that Log4j, it would be convenient to have a lookup for Yindi resources in Log4j. So why does a logging library need Yindi lookups? Well, you can, for example, think that it might be handy to have centralized. I don't know. You need to configure some logs centralized. For example, you want to configure the log settings or the log level in, let's say, an LDAP server. So why LDAP? Because you have a centralized LDAP running already. So you configure your log level in an LDAP server, and you configure Log4j. Whenever the application starts up, it queries the LDAP server, reads the log level, and configures it. If you have 100 applications, that you want to configure, and you need to make an update in the log level. You update the LDAP field, restart your applications, or have them automatically reread the entry, and then you basically have centralized configuration. So is this something that's used a lot? I wouldn't say so, because nowadays probably you're more familiar with using a config server like maybe Console or AWS config, or I don't know, the Kubernetes config server to have centralized configuration of variables. But the feature was still present in Log4j, and that's the reason, one of the reasons behind this vulnerability. So to give you an overview, Log4j 1.x is not affected at all. So if you're running on Log4j 1.x, you're fine. Log4j 2.x has 3 vulnerabilities. So one is about remote code execution in all versions prior to 2.14.1. One is about environment variable leaking, which is the same CV that we'll see in a demo by Roy shortly. So you're basically leaking to an attacker variables that are defined in your environment. And there's a fairly new, well, all these vulnerabilities are new, but there's an even new one in Log4j earlier or equal to 2.15, and there's a denial of service vulnerability. But this seems a lot less impactful than the other two. It's a lot harder to exploit, and the impact could be a minor denial of service, but it's less severe than the other ones. On the other hand, while you're at it, our advice definitely is to upgrade to 2.16.0. And then Logback, we'll look into this in a bit. There's also a remote code execution vulnerability in Logback. So I think when this vulnerability came out in Log4j, well, the world was shook, obviously, but there was also, I think, a sigh of relief, because most Spring and Spring Boot projects don't depend on Log4j 2 core. So Log4j 2 core is where the vulnerability is in, while most Spring projects only use the Log4j API and depend on Logback for the implementation. So most Spring projects were not vulnerable to this vulnerability. And then a vulnerability in Logback was discovered, but here it's only in the Logback configuration file. So in order to exploit this, an attacker needs to have write access to the local file system of the application, which is, I'd say, a lot harder to exploit, because you already need write access to the file system, a lot harder to exploit than the Log4j vulnerability. So to give you an overview of the vulnerability, how can it be exploited? On the left, we have a hacker, an attacker, and on that could be Roy, yes. And on the right side, we have a vulnerable Java application. So the hacker starts with sending a request, an HTTP request, where in some field there is a Jindy string configured. So what we're seeing here is there's a Jindy prefix and saying connect to LDAP server named attackerserve.com and go to LDAP resource foo. So if the application in some way takes user input and logs it, so it could be logging a header, or it could be some field in a request parameter that you log, as soon as it's possible to, as an attacker, to influence the text in any log message that's logged by Log4j2, then you're basically vulnerable. So what happens here is, let's say that we're logging the request parameter or request URL, then this message gets parsed by Log4j. And it results in an LDAP query being done to the URL in the Jindy request. So it's going to make an LDAP query to attackerserve.com. The attacker has set up a rogue LDAP server on attackerserve.com, and they are sending back a Jindy reference, which is saying, okay, the Java code base is on this URL, the class name is exploit, and the object class is a Java naming reference, which is a Jindy name. The LDAP server of the attacker sends back a response to the vulnerable application, which in a response wants to fetch the reference to the Java code base. So it makes an HTTP GET to the attackerserve.com server. It fetches exploit.class, so it's a class file, and it sends back an HTTP response and will then load this class. So a typical exploit could be that this class, when it's being loaded, a static initialization block is being executed, and basically whatever you put here will be executed by the server running the vulnerable server. So this could be, in this case, a shell command that tries to clear out the file system. It could be a system.exit1 that terminates JVM. It could be a curl command that posts the contents of etc. password to some remote server that's listening for this. So while thinking about this, Roy, one thing pops in my mind. The exploit class, it should probably be compiled in with a Java version that's supported on the vulnerable machine, right?
Yes, that's some of the things you need to consider.
Yeah, but probably if it's compiled in Java 8, then it will work on any version on Java 8 and up,
Exactly.
I guess. Yeah,
exactly.
Okay.
So use the Java version as old as you can get.
Yeah. All right. So send a Ginny string, send back a rogue LDAP response with a exploit, and you're good to go. So I think it's time that we hand over to you, Roy, and let's see the vulnerability in action.
Okay. Let's share my screen. Can you see everything?
Yes, looks good.
Okay, so for this demo, I just went to start.spring.io and I created the most simple Spring project you could have, including Spring Web. I chose Java 8. Not really sure why, and that's it. And if you would look at this code, this application, it's a simple Spring application. We run it. This property isn't used yet. And the only thing I changed in the Maven file was that I excluded the default logging from Spring Boot and Spring Boot Starter Web. And I added Log4J, obviously. Then I added a small REST endpoint. And this REST endpoint is called a logging endpoint, and it has a mapping to /log, so we can call /log, and there's a request parameter, and we can just give it a string. And the only thing that happens to this string is that logger.info is called, and it says received, and it returns this string. And that's it. So if I open my consoles, let's clear everything. I've got it running right here. If I would go to localhost 8080 /log/payload with hello world, nothing happens. There it is. Hello world is being printed. And that just means that this REST endpoint is working on 88. We can log messages there. We can say, hello, YouTube, and we get a response back. This is our entry point into, this allows me to quickly make some Log4j messages, and we can play around with the vulnerability. As you can see below, I'm also running an evil LDAP server. And this LDAP server is basically what Bert-Jan just showed. If you connect to this LDAP server, it will listen to, well, on some port, and it goes to /test. As you can see, two things happen. First, the thing that the LDAP server, it basically doesn't return anything. So you get a GNDI invalid name exception. We can skip that, but we also see it actually printed out the string, basically the payload, the vulnerability. But on the evil LDAP server, we can see that it also received this. So your application could just be running, and somebody could put this string into their HTTP headers, or they could use this in a comment section, or they post this as a username, or they add this to the request parameters, or they encode it into a URL or something. Maybe some 404 page is logged that some page isn't found. You can just put your string into the URL, force a 404 exception, and you're in. Basically, it gets called, and the evil LDAP server will get a request.
As one remark, Roy, for
Yes.
this to work, obviously the Yindi URL and the LDAP server that you send as a request parameter must be reachable from the vulnerable application.
Of course.
So
yeah.
Typically you would exploit this by having some publicly accessible rogue LDAP server on the internet and then sending a reference to this server in a parameter.
Yeah, so basically this embedded LDAP server is it's just a couple of lines of code. We'll quickly look over it in a couple of minutes. But you could just connect this somewhere on the internet, put it on the Google Cloud, put it on Oracle Cloud, of course, can't forget the Oracle Cloud, or on AWS, and just spam this string, and you can find vulnerable servers because they will ping you. They will say, I'm vulnerable, which is already not a good thing. But it can get even worse. Look, for example, if we use this payload, it still connects using GNDI to the evil server, but now it has the Java home variable added to it. And if we open this, it will give the exception again, and it will parse this. And as you can see, now I've passed this environment variable to the evil server. And I can get every possible environment variable. For example, what's my username? Or I don't know, what do I start Maven with? My Maven opts. And you can see all these variables are just being passed to the evil LDAP server. This already is really bad. You would rather not have this. For example, if you have some AWS keys or you have some secret information in an environment variable, just consider it lost. It's probably lost.
Yeah, this could also be maybe the credentials that you use to connect to your database, or some other access key, or especially if you're running in Kubernetes, then most of the config is typically injected via system properties or environment variables. So these are all at risk.
Yeah, exactly. Just like you said, there's even a Kubernetes shortcut to get all Kubernetes information, and you can get system properties, etc. So a lot of information can be leaked using this, but it gets way worse. For example, let's look at the GNDI LDAP server /attack1. But first, let's take a look at what the embedded server actually does. So it actually consists of two parts. It's the LDAP server, which is running on port 1389, but I'm also running Jetty on 1388. And this Jetty serves my index.html, is the one I'm using here, but it also serves everything in the static directory, and there's a payload.class. There's no Java object here. I'm just putting the class file in as a static file. And as you can see, it's being disassembled here. It implements Object Factory. And because it implements Object Factory, we don't get this exception by Log4j. And what it does is the following. It prints out something, and then it opens the calculator. That's because for some reason, every remote code execution I've ever seen, they always open the calculator. So I'm doing the same thing. What does this LDAP server actually return? Well, we've seen it before. It's about this. So we say there's a payload object. It's on the evil server 1388, and it's a Java naming reference. And this is the name of the object we need to download. And
so when I first saw this, I had the idea that this obviously is a recipe for an issue like this, right? So there's the fact that there's support in GNDI for retrieving a Java class from an LDAP server, you could say in itself is a risk. On the other hand, I think this is because of you might be able to fetch some configuration class, like a Pojo that has some fields that you want to use in your application. And obviously you're not thinking about classes that actually execute logic, I would guess.
Yeah. What surprises me is that it just downloads a class file and puts it on the class path. Like that's the thing I really don't understand. But let's look at the logs again, and let's do the attack. And it's just scary that this works. Like instantly, it opens my calculator. We can see here on the Spring Boot application, which is just one line. It's logger.info. It injected my code, and it's now, every time I refresh this, I get a new calculator. So this is really, really, really bad. And this is also, there are two reasons why this vulnerability is so dangerous. The first one is it's very easy to spread a string like this. There are like thousands of ways for it to get logged, and it's impossible to check every log message, log statement you have if there's a possibility of user input. Most log statements have some user input, either a URL or username or something. It needs context, so you're logging stuff. So there are thousands of ways to get your evil string into this system. And it just goes to the evil LDAP, downloads a class file, whatever class file, and it runs it. Okay, so initially when this was released, a lot of people thought they were safe because they were using a modern Java version. So in this case, I'm using an older Java version, which has that property I just showed. Let me quickly go here. So now I'm on the latest Java version, 3.11. And the property I showed before, it's here, this trust URL code base. It's also in the application. So let me enable this as well, because I'm using a newer Java version. This is already set to false, but the trust URL code base eliminates the second step that Bert-Jan showed earlier. So the first step is it goes to the LDAP server. It gets back this, this reference, this part. The second step is that it goes to this URL and actually downloads the class file. So with this set to false, this step is eliminated. It no longer downloads classes it doesn't know. And that's a good thing. For the next demo though, I want to add one more dependency, and I'm gonna add commons collections. And now I can't see the Maven refresh knob button because Bert-Jan's face is in the way. Okay, I refreshed everything. Let's quickly restart the vulnerable application.
So it's not, it now should not be vulnerable anymore to fetching the exploit from the remote LDAP server, right? Because the trust URL code base is now set to false.
Yeah, it should, but for some reason it didn't pick up the Java version yet. So let's do it again. I wanted to show a new Java version, obviously. Why is it not picking up? Why are you not using? Oh, there are two ways to
module settings.
Yeah, great. It's the demo effect. Okay, let's restart it.
Yes,
that's better. Now it's the latest Java version. And if everything's okay, we hope that this vulnerability is no longer present. And luckily, you can see that just by using a higher Java version, we now get a reference class name, and it doesn't go fetch the class and actually do that.
But the environment leak is still in there, right?
But as you can see, it still calls the LDAP server. It still gets the name here. So the dangerous part is that we can, this leak, for example, with the Java version, everything on your environment is still vulnerable. And it's even worse because even though it doesn't go and fetch a class file, a trusted class file, it will happily create everything that's already on your class path. So let's look at the evil server again, and let's look at the attack number 2. So in attack number 2, we have some class name, but now we pass in serialized data. And we still give it the Java name reference. And this serialized data basically is the state of a couple of Java objects being sent over the line. Even on the latest Java version with the trust URL code base set to false, this serialization goes perfectly. And whatever object we send, if it's already on the class path of the vulnerable machine, it will just happily create this. So this is a way to very easily do all kinds of serialization issues. And for example, right here, what I'm currently sending is something that's in the commons collections. We create some object, we write it to an object output stream, and we return the byte array. So this is just the serialized data sending over the line. But what we're actually sending is this. It's some tied map entry with a lazy decorator and some transformers. But these transformers aren't what you would usually use. This is a transformer which acts on runtime. And what it does, it gets the runtime and it opens the calculator. So this was made like very flexible. You can basically transform everything with this, but that's a risk. And with the Log4j vulnerability, we can just create these objects on the server just by putting our string everywhere. So it's an entry point combined with other attacks. It's very easy still to get in the server, even if you're not using if you're using the latest Java version and you've set that thing to false. So let's see that running as well.
A question, Roy, to build my understanding. So
yes.
You are now no longer depending on an exploit class file that you transfer from a remote server, but you're only depending on classes that are already on the class path of the vulnerable server, right?
Exactly.
And you instruct those classes to do something by sending a serialized, well, Java object structure to the remote server, and then this will how will this be picked up by the classes present in the remote server?
The great thing is because Log4j gets an object, and this object, it wants to display it, so it calls toString on it. And the comments collections vulnerability you just saw works on the toString method. So when toString is called, it wants to prettify the map. It loads up all these transformers, but they're evil transformers, and they evil transformers. That sounds like a good movie. But it does something, and in this case, it runs the calculator.
Yeah. So the attack vector is comparable to having something in a static initialization block. It is executed once this object is processed by let's say the logging chain.
Yeah, and there are a lot of serialization vulnerabilities known, even in a lot of popular frameworks. But usually, like the one we just saw in comments collections, be sure to upgrade to a later comments collections if you are using that. But it didn't get this attention because it's very hard to trigger this, because in which scenario are you able to put serialized data on a server? Like normally, that's a very hard thing to do. But with Log4j now, that's very easy to do, even if you're running the latest Java 8 version, and you've set this trust download thing to false. Let's quickly demo that as well. And as you can see, with attack 2 called, we're sending serialized remote execution. And here below, you can see it's not even throwing an exception because it can just on the Unix process do a toString. And it just works. I saw some claims online that if you have a more modern Java version, you're safe. Maybe not. You're at least not safe for leaking information, but there are a lot of attack vectors that this still enables. Yeah. So what do you do to actually stop this attack? Well, it's very easy. The best way, in my opinion, and we'll go over some other methods in the slides, but the best way is just to upgrade to a later Log4j version or Log4j version. Okay. Let's quickly update and restart. And now if we do the hello world, that still works, obviously. But if we do something like the first attack, nothing is sent to the LDAP server, which is what we want. And the second attack, again, nothing is sent to the LDAP server. So they've now, by default, disabled this entire lookup, which is way better. And yeah, but let's stop sharing my screen and let's go back to the slides, because you've got some more information about what you can and what you should do.
Yes, so I will start sharing my screen again. All right, let me fix the stream again. Okay, good to go.
Put them in the chat.
So, one step back to Logback. How about Logback? There was some fuss about Logback having a vulnerability as well. There is remote code execution in Logback prior to version 127. It's also GNDI injection, but it's in the Logback configuration file. The Logback configuration file also allows GND lookups, but this vulnerability is significantly harder to exploit, because in order to exploit this, the hacker needs to be able to make changes in the Logback configuration file. So the attacker needs write access to the local file system where your application is running. And also, if you can write to the Logback configuration file, then you also need a way as an attacker to be able to have this change being picked up. So this is easy if you have auto reload enabled for Logback, which is, I'd say, convenience that many projects have. This is the scan is true parameter, or whenever your app restarts and reloads its config file. So if you have scan is true configured and an attacker has write access to the Logback configuration file, then there's the same vulnerability as possible with GNDI injection. But this is a lot less feasible, because if an attacker has write access to your file system, then probably you're in bigger trouble. On the other hand, there might be, I don't know, some broken upload functionality in your app that allows an attacker to write to an arbitrary file on the file system. So remediation here is to update to Logback 128 as soon as possible. You can also set the, as a temporary measure, set the Logback configuration file to read only. So only to root, make it readable but not writable for the user where the application is running under. So how do you remediate or how do you protect yourself from the Log4Shell vulnerability? This is the Log4Shell remediation cheat sheet created by our friends from Snyk, which is a security tools company. You can find the original cheat sheet at the Snyk blog. The URL is listed in the bottom of my slide. And we'll dive into all these steps one by one to see what you can do. So I think first, with every vulnerability, is trying to gain visibility of the impact. So find out where are you using Log4j. There are tools from Snyk you can use, but obviously you can also run Maven dependency tree and look for Log4j to see where in your Maven project you're using Log4j. It might not be in your primary code base, but it might be a transitive dependency that's being pulled in. So it's good to do this for every project that you have running.
Yeah, also to add, I saw a tweet by Martijn Dashorst. And he also said there are a lot of projects that just copied all the Log4j classes into their jar file. So it might not even be enough to scan for dependencies that are from Log4j, but some projects even copy the entire code base into their jar files and make like a fat jar. So yeah, you have to really thoroughly search for Log4j.
Yeah, so how would you scan for this? You need to, well, you might need to unzip all your jar files and then grab the directory structure for Log4j. But what if your jar file has a jar file that includes a jar file that includes classes for Log4j?
Yeah, you can there are search engines to look for classes in any Maven jar files. You can go to I'll share the link. You can go to a website, you can enter some of the Log4j classes, and you can see which jar files actually contain these classes. That's a good hint.
So we have a question by Rijn Vogel. And Rijn is saying, well, by default in Spring Boot, Logback config is baked in, right? And it's typically overridden by Spring Logback, or is it Logback Spring? Yes, the need Logback Spring.xml. This is indeed where you can override the default config. I think the fact that it's defined by default in Spring, well, doesn't really help you much, because if the attacker can write a custom Logback configuration file, then you're still in trouble. But I think that the scanning of the scan parameter that auto reloads your Logback configuration file is by default set to false. So you're only vulnerable if you either have this set manually to true, or obviously if somebody else writes access and you restart your app and you pick up the changes. But then it takes longer for the changes in the Logback file to be effective. Marijn, I hope that answers your question. If not, feel free to ask again.
Yes.
Update your Log4j version to 2.16.0 by updating your Maven dependency.
Yeah, and if you
also yeah, go ahead.
You were really quick to update to 2.15. well, you've practiced, you can do it again now. That's like another slap in the face for all the Java programmers.
Yeah, the only change in 2.16 is, I think, a fix on the fix that was in 2.15, right? So it should be a fairly compatible upgrade.
Yeah.
What you also can do, if you're, for example, not able to upgrade to 2.16, you can remove the Jindy lookup and supporting classes from your jars. So you can manually patch the Log4j core jar, and you can remove the Jindy lookup class there. And there are also other classes that you should remove, like the Jindy manager, JMS appender, and SZB appender. And once you remove those, you need to restart your JVM to make sure that the jar file is loaded again by the class loader. And it may obviously cause unexpected runtime behavior because a class is missing there. You can set properties. So if you are on Log4j between 2.10 and 2.14, you can set Log4j format message no lookups to true, or set an environment variable. Are we completely safe with Log4j 2.10 if you set this, Roy?
I think so. It doesn't do the lookups anymore. So,
yeah.
But make sure you have Log4j 2.10, because there are older versions of Log4j which are still vulnerable and just don't even listen to this flag. So,
yeah. So one, if you are, for example, running in Kubernetes or running on a path like Cloud Foundry, then it is something that probably you could set as a system-wide variable to quickly fix a multitude of applications. Just setting this parameter obviously is never enough. You still need to check whether you're vulnerable to this vulnerability to make sure that the parameter was picked up and that it's actually helping, because you might have one app that's running on an older version where this parameter is not effective.
Yeah, I also noticed there was someone who was running an evil LDAP server, which we just saw. And the remote code execution that it did was actually set this parameter. So by breaking in, they fixed themselves. Like they closed.
Oh, that's interesting.
Like a vaccine.
So yeah, so you make a class file that in a static initialization block does system.set property, etc.
Exactly. So it self-patches itself.
That's a creative way to patch your applications,
nice,
right?
Yeah, that was very cool.
Upgrading your JDK isn't enough. Well, that's what we've seen, right? Even on really modern JDKs, you still have a problem if you don't upgrade or you don't set the flag to disable the lookups. The next one is about restricting data to the internet. So it says Kubernetes policies or other. I think in general, it's a good idea to configure the network rules for your application in a way that it's not allowed to make any outgoing connections to the internet, because most applications don't need to make outgoing connections to the internet, right? They might need to go to some Docker registry or to an internal registry or to some external services, but then you could whitelist those, either based on IP level, or you could add a proxy that only whitelists specific hosts. So if your application is not able to make the LDAP connection back to the remote evil LDAP server on the internet because you're blocking internet access, well, then you're safe for most attacks. It doesn't obviously stop from accessing malicious LDAP servers that are already within your network. Obviously blocking outgoing traffic doesn't mean that your application cannot receive any requests. So you're still fine to receive incoming requests on port 443. But as long as you block outgoing connections, then they shouldn't be able to connect to the remote LDAP server anymore. So we have some comments. Jeroen says, I assume you're safe when you only allow whitelist external URLs via proxy. Yeah, that's exactly what I said, I guess, right? And configure the firewall, yes. Xtermi asks, am I affected if I have only Log4j API and not Log4j core? I think the vulnerability is in Log4j core, right? So if you don't depend on Log4j core, you should be safe.
I think so, but better to be safe than sorry. Check if the GNDI lookup is there, and it's not very hard to. There are websites where you can just get a string that you can put in your log file and see if it triggers.
Yep. All right. And obviously you can set up your projects with some automated tool to upgrade vulnerable dependencies. Sneak has tools, Dependabot can work here. So there are loads of tools that can monitor your Maven dependencies, your NPM dependencies for known vulnerabilities, and automatically make pull requests that upgrade the vulnerable dependency. And if you have a WAF, a web application firewall, then you can also add rules that will block these types of requests, because probably you don't need end users, valid end users, to have these types of requests in your application. So obviously blocking these in a firewall should only be a last resort. On the other hand, a sound security strategy is typically a defense in depth. So you try to have multiple levels of defense. You have a web application firewall that blocks malicious requests. You're blocking outgoing traffic. If you would have had those two, even with a vulnerable application, chances that you're actively being exploited are a lot lower, I'd say. But obviously, if you configure these firewall rules wrong, then you might also be blocking actual well-behaving users. So you can download the entire cheat sheet at the Sneak blog. Feel free to fetch it there. It's PDF that's easy to share. So thanks, Sneak, for sharing this with us. Then another interesting initiative is Log4J hot patch. This was created by the Amazon Corretto team, actually by Volker Simonis, who used to work also at the SAP Java virtual machine. So he's a fairly well-known JVM developer. And Log4j hot patch is a tool that injects a Java agent into a running process. And this agent will, I think, probably by manipulating bytecode, try to patch the lookup method of JIND lookup, and to not do anything but return a string that's a patch lookup. So this is a tool that you can use to basically patch a running JVM, a running application, to mitigate the vulnerability without restarting the Java process. So it's an interesting approach, but I'd say also a bit more advanced approach for if you need to, I don't know, patch loads of services and you don't have time to make a new build and deploy them, or you don't have time to restart them, or you cannot restart them. I say use this as just an option in your toolbox. I'd say the final long-term option is to make sure that you're using a patched version of Log4j in all your applications. So once this is all over, and we don't know when this will be, but is there a life after Log4Shell? What do you think, Roy? How does a life after Log4Shell look like?
Well, actually, it probably starts right now, because I think a lot of people have been patching systems over the weekend and over the last couple of days. So I think within maybe reasonable time, most applications won't have this vulnerability anymore. But that's just part of the issue, right? I think with the widespread exploitation of this, everything that you had, every key that you had, for example, on your environment or in your system, consider it lost. So
yeah, I think that's good. That's good as far. So
yeah.
Let's look into some more detail there, because I think one thing that's key is that you make a really good assessment to know whether you at some point in time have been vulnerable or not, regardless of whether you were exploited or not. But make really sure that you know if there's one or more applications that have been vulnerable because you were running on the internet with an application with a vulnerable Log4j version. And in case you think you were not vulnerable, please check again. So how do you know, Roy? What can you do to check whether you have been running a vulnerable version anywhere?
Yeah, again, scan all your class files, look at if this JNDI lookup from Apache is there. Also, look in your log files, look for the particular patterns if people have been trying to abuse this. Chances are, yeah, it's probably in some username or in some comment in your system.
Yeah. In case you were vulnerable, so in case that you found out that at some point in time, you have been vulnerable in an application that was accessible by any external users, or maybe even internal users, and any users at all.
Yeah, especially
I think you should,
last week, like for since this has been live, I'm not a hacker. I'm not a security guy. I'm just someone who knows how to Google, and I could find this this vulnerability like easy. It's all over the internet. That's also why we're showing it here. It's been fixed. It's been and there are a lot of repositories already that have this code in it. We're not going to share the code if people wanted to have this and want to ask. If you want to test this, you can contact us. Maybe we can send up a waiver or something for the liability. Then we might be able to share the code or help you find out. Yeah, just want to say that. Yeah. It's everywhere. So assume it's done.
Yeah. So, well, this vulnerability has been around for a while. So even if you've only been vulnerable for last week, I think you still could be in trouble, but obviously it was a lot less widespread because it was not publicly known. But we don't know how many people knew of this vulnerability before last week. So I'd say you should consider your application server compromised. Whether it was accessed by an attacker or not, it could have been accessed by anyone, and this person could have either executed remote code or read your environment variable. So you should consider your application compromised in a way that somebody has had actual access to the server, being able to read application files and being able to execute arbitrary Java class files. So what does this mean? It means you should take evasive actions, right? So if there are any credentials that are in the application, in the config files, in the any servers that are accessible from those servers, and any environment parameters, you should rotate them. So create new ones and configure them in both your application and the server that's accessing. There might be backdoors installed on your application. So rebuild your app instances. If it's a Docker image, okay, then probably you're fine with redeploying the Docker image, but also look at any volumes that are mounted. If it's a server that you build automatically, rebuild it. If it's a server that you've built manually, so by logging in, SSHing, configuring stuff, strongly consider to move to a new machine or to rebuild and reconfigure the machine, because there could be installed something somewhere by an attacker that used this vulnerability. Then redeploy everything. So once you've rebuilt your app instance, redeploy all your applications so that you're sure that the patched version is installed, that the new credentials are being used, and that everything is running on your rebuilt app instances. And obviously start a forensic search through your logs. So start looking whether you can find any traces of people accessing it with any let's say Jindy strings that could have done something that you don't want. So start going through your log to seeing if you can find any trace of people actually trying to abuse this. It doesn't really matter from perspective of that you should consider your server compromised, but it does give you more insights on the chances that you're actually compromised.
Yeah, exactly. Looking at the chat, some people are saying, well, only if you log web requests, etc. But there are like millions of ways this string could end up in your log file. It's not just web requests. It's some database field could have this this vulnerability. Maybe you're parsing emails. Maybe it's in a URL somewhere. Maybe it's in somebody's email address. You can basically every input field, either a form or anything that's connected to your application that's logging stuff, could have this string in it. It's not just requests to a REST endpoint. It's everywhere.
So Jano asks if you have some tips on finding those in the logs and hunting patterns. I think the patterns that we shared for the web application firewall are a good start. So definitely search for Yindi, but maybe in any of these, let's say mutations of these requests with any other placeholders. Look for Yindi, look for LDAP, look maybe even for this $sign.
Start by looking at the $sign and the accolade. That's every expression language statement starts with this. So that's a good start.
Yeah. All right, where are we? We were here. Yes, and do note that the vulnerability has been disclosed recently, but has been present for years. So we don't want to cause any widespread panic, but it is possible that this has been abused already years ago. Chances are, I think, smaller, but well, we don't know.
It has been known for years. It has been actively known and used for weeks, but that issue has been known for years. And it was actually first publicized in a Minecraft chat, where people running Minecraft, the chat was compromised and people were asking questions. And it turns out that this was actually the cause of that.
Yeah. So Jano says that the link we shared includes a couple of grep commands to reuse. Exactly. Jano, can you point to which link this is?
I think that's the one with you just shown. That's
the one in the, oh, sorry about that. The one in the, I think my keynote just crashed. The one in the SNCC report. Exactly. Okay. Yes, my keynote just crashed. I hope nobody is trying to do any remote code execution. So it's here in the SNCC remediation cheat sheet. All right. So we've had this. Yes. All right. So any references and further reading. I don't expect you to read all this now, but we'll share the slides on our Meetup page and on Twitter afterwards. Most of the stuff that we shared here was based on information found in all these links. So Roy has blogged about it, as Log4J's info, Lunasec has info, the CVEs are interesting to look at. If you're interested in the Logback issue, you can look at the Logback site. SNCC has some great information. Microsoft has updated today a quite extensive research blog post about the issue. The image I showed with the timelines was shared by JFrog, and SNCC has also created a awesome Log4Shell Git repo where there are loads and other links for further reading.
Yeah, and also
so I think yes,
if you want any help, like we kind of know a lot of stuff about this vulnerability now. We've done research this week, and we're happy to help. So contact us. Contact OpenValue.
Yes. So how can people contact us?
That's probably on the next slide, isn't it?
That's a great intro. Yes, feel free to contact us on Twitter. Roy and I are both on Twitter. You can also email us. You can also just go to openvalue.eu and then you'll find contact info there. Thanks a lot for joining. We're happy to take any questions you might have now. This recording is immediately now available on our YouTube channel, youtube.com/openvalue. So if you want to share it with somebody, feel free to link it to there. If there are any other questions, we're happy to take them now.
Yeah, and at the moment they are not in the chat yet, but maybe it's just very
we have about you have about 10 seconds to ask questions, and otherwise we'll close the stream, and then you're happy to reach out to us on Twitter or on email.
Yeah, thanks for watching, and let's hope we don't have to do this anytime soon again.
Likewise. All right, so everyone, thanks a lot for joining, and we hope to be back again soon, but with a different topic, I think. Thank you, and have a good evening.
you.